All right, what we're going to do in this little video is we're going to, together as a class, draw these particles. We're going to use a small number of particles. We're not going to try to draw them all. We'll draw our particles as different shapes for the different substances. We'll have particles for water, the glass of the thermometer, and the fluid inside the thermometer. We're going to try to use some colors. I may not use all these colors. I'll probably just use maybe green, yellow, and red to show the color change, because we really have something green, let's just say, is a room temperature particles. We'll also try to show the space between the particles to show how the volume of the substance will change as the substance warms. So to get started, we're going to choose different symbols to represent the substances. So I'm going to use a square, and that's going to be water. So the water particles will have a square shape. I'm going to use a triangle to represent the glass. And I'm going to use a circle to represent the fluid in the thermometer. So at the start, I've got hot water, and I have a room temperature thermometer. So I'm going to first draw the hot particles. So we're going to use squares for that. So for the water particles, I'm really not going to worry so much about the spacing. I'm just going to draw some water particles. And that's pretty good. Now, at the start, the temperature of the thermometer is going to be room temperature. So I'm going to use green to represent a room temperature speed. So the glass is going to be at room temperature. And the fluid inside the thermometer is also going to be at room temperature. Here we go. So I'm done with that. Now, the thermometer glass warms. Well, in order for something to warm, the heat's going to be transferred from the whatever is hot to the next coolest thing. So I'm going to have red water molecules. Notice I'm not drawing them right next to the glass. Now, when one of those red water molecules hits the glass, it's going to slow down. It's going to transfer its energy to the glass. So wherever these are hitting the glass, it's going to end up speeding up the glass particles. Now, a lot of them, of course, are still going to be traveling at the same speed. And all my water molecules are also still going to be traveling at the same speed. They're also going to be spaced about the same distance apart as they were before. Now, in the next one, the thermometer fluid warms. So, starting from the outside, I still have fast-moving water particles, because remember, there's a lot more water molecules than are going to be in my glass of the thermometer or the fluid in the thermometer. But some of these particles have contacted the glass. Their speed has slowed down a little bit. And of course, some are still in the process of hitting it. When they hit, it transfers the energy to the glass. Some of the glass is still, the particles are moving at a slower speed, but more of the particles are moving at that faster speed. Now, the distance between the particles, this is a solid, the glass is solid. So the distance is going to change between these particles, but it's not going to change much. It's not going to change so much that it's going to turn it into a liquid. So I'm going to add a couple more little green ones. Now, it says the thermometer fluid warms. Well, wherever these faster moving particles are hitting the fluid, it's going to cause the fluid to move a little faster. Now, the fluid, remember, is separated already. The distance between the particles is greater. So these are going to actually spread out farther. If the particles are spread out and there's more distance between them, it's going to increase our volume. So our volume is actually going to go up. Some of these particles are still moving slower, but I've got an increase in volume because they're spread out. Now at the end, what I should find is some of these particles of the liquid are now moving slower. A lot of them are still moving fast. In fact, most of them are going to be moving fast because there's so many of them. Some of the water molecules are moving at the medium speed. The particles of the glass, some of them are still moving at a medium speed. Some are moving at a slower speed. And some of them are even moving at a fast speed. Now the distance between them, again, is going to stay about the same because the attraction between the molecules is pretty strong. So the glass is expanding, but it's not expanding enough that we're going to actually draw that. Now for the fluid inside the thermometer. We've got some particles that are still moving slow. Oops, sorry, wrong color. We've got some particles that are moving at the medium speed. And we've got a few particles that are moving fast. Now, the distance between the particles has increased. So my thermometer is actually going up. And what I should find is that at the end, when everything's finished changing, you're going to find the average, the average speed of all three materials is the same. So the heat transfer has gone from the outside to the next layer. Actually, let's use. And then from the next layer, from here to here, speeding up the molecules. And this just continues to go from one layer to the next until everything is the same. And that's our drawing.